This is Geometry, Unit 4, Day 2. Again, we're going to work with the triangle sum theorem. There's a special one that we're going to talk about today called exterior angle theorem. And what we're going to look at is that the exterior angle, the one on the outside, is going to equal the sum of the two angles inside the triangle that is not next to this one. So we're going to start out with angle 1 and angle ACB. They're a linear pair. Okay? If a linear pair, then the angles are supplementary. We know that the two angles are going to add up to 180. If supplementary, then the sum is 180. So we say that angle 1 and angle ACB add up to 180, because if they're supplementary, then their sum is 180. Then is happening now. Supplementary was happening earlier. Angle AB and ACB equals 180. That was that triangle we had learned in the previous lesson. If triangle, then the interior angles have a sum of 180. Two different things are equaling 180, so two different things equal each other. So now you're looking to see, how did we get down to the measure of angle 1 equals the measure of angle A and B? Well, the piece that they're getting rid of that's the same is the measure of angle ACB, and the measure of angle ACB, that's missing. So that's called the subtraction. Property of equality. So what that proof does, it helps reinforce that this exterior angle theorem exists. That you can take an exterior angle and add that up to the two interior angles that are not next to it. So here we are, the measure of the exterior angle. In this case we'll say angle 1. Recall that an exterior angle is made by extending a side of a triangle. It can't just come off at any angle. It has to be an extension of a specific side of the triangle. The exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. So angle 1 is your outside angle, called your exterior angle. The measure of angle A and B are the two angles that are not next to it in this case. So let's practice that down here in example 1. Notice that this is an extension of a side. We have 3x minus 9. So I know that 3x minus 9 equals the sum of the two non-adjacent angles. So x plus 73. So I'll subtract my x, add the 9. So I get 2x and 82. So when we divide by 2, we get x equals 41. If we're looking for the measure of angle DCB, the measure of angle DCB is going to equal 3 times that 41 minus 9. That's 123 minus 9, which is 114 degrees. Here we have the measure of angle ABC. That is supposed to be 47. The measure of angle CAB, which is x minus 3. And then the measure of angle ACD, which is supposed to be 7x minus 4. We're going to find the measurement of angle BAC. Well, here's your exterior angle. the two angles not next to that, the two interior angles not next to that, would be x minus 3 and 47. So we'll subtract x. We can add the 4. So in this case, when we divide, we get an x value of 8. 6 times 8 is 48. So 48 divided by 6 is 8. They want us to know the measurement of angle BAC. That is going to be 8 minus 3. So that gives us 5 degrees. The picture's not drawn to scale. This isn't 47 degrees. This is much closer to 90. So just check your work to be sure that you've set up your problem, even if it doesn't quite look like it, and we can support that this is truly set up correctly and solved right. So we're going to stick with 5 degrees. Here's a tricky one. We're looking for the value of x and y. We have two parallel lines. We're supposed to be considering something as immediate as we hear parallel lines, and that is to look for certain types of angles. Alternate interior angles, which make a Z shape. That's what we have here. So x has to be 43 degrees. It almost looks like we have corresponding angles, but we don't have them that are touching parallel lines, or a transversal that is touching those two. So that's got to be ruled out. We have an exterior angle, which is an extension of a side on the outside. That angle is going to equal the sum of the two inside. So y is going to be 32 degrees. Here, we're going to look at this proof. We're starting with a triangle. We're going to prove that angle A and angle B, those are your two acute angles of this right triangle, that they have to be complementary. So remember, whenever you do a proof, you want to come up with a plan. That means to look at your proof, look at your picture, look at what you're trying to reach, given your information, how can we get there? Don't look at the proof itself. Try to explain this or understand how this is possible before you ever try your proof. Well, I know previously that these three angles might add up to 180 degrees because it's a triangle. One of those angles is 90. So if I subtract 90 from both sides, I'm left with A and B that have to equal 90. And that will make them complementary. Seemed like a pretty good proof. Here we're going to start out with our given, which is a triangle. The measure of angle A plus the measure of angle B plus the measure of angle C is 180 degrees. So if triangle, then sum equals 180 degrees. Okay. We know, because we have a right triangle, oh, hang on a second. It looks like, since this was a proof and we were doing it in the order that it was pre-written, if triangle, then interior angle sum 180. It looks like they want to do that step down here. So we can't force it sometimes when we're following their predetermined method here. So we're going to have to try that one again. So we'll come across and get rid of that statement. There's more than one way to explain. I was just going to make that statement earlier. They want to share that later. So looking at the information that they have here, they want to share that spot later on. If triangle, then interior angles have a sum of 180. That would be the A, B, and C adding up to 180. We need to know that angle C is a right angle. If right triangle, then right angle. Remember, the if is always what we've been given earlier. The then is happening right now. So the only thing we've talked about earlier is a right triangle. Then it says if right angle, then its measure's going to be 90 degrees. Then we talked about the sum of the three added together, and we substituted it in, called substitution property of equality. Remember, that's equality and not of congruence. Equality is when it's an equal sign. Subtraction property is when we subtract the 90 to the other side. If sum of two angles is 90, then they are complementary. And that's our shortcut here. It's called a corollary. It's kind of a branch off of our theorem that when we learned about the triangle sum theorem. The acute angles of a right triangle are complementary. So that can help shorten up the amount of work that you have to do when you're trying to solve these problems. So we know that angle A and angle B are going to add to be 90 degrees. So the shortcut is going to be the measure of angle A plus the measure of angle B. You could say C if you wanted to, add it to 180, but the shortcut that we've learned about says that the acute angles, the small angles of a right triangle, have to be 90 themselves. So then we substitute in our value that we know. A is 22. Subtract it. We get 68 degrees. Here we're looking for the values of x and y. Here's x, and here's y. They're probably not the same measure of each other. We know, if you see this big triangle here, we notice that 85 is the exterior angle to that. So 85 equals the sum of the other two non-adjacent angles. So we know that angle Y has to be 60. Here's another exterior angle. The 60 and the x have to add together to equal that exterior angle. So now we know that angle x would have to be 30 degrees. There's more than one way to do that. You could take this triangle and solve for that angle. You could do alternate, or actually vertical angles, and go inside, become there, would be the same as that, and then you could add up to 180. So there's multiple ways to have gotten there, and they all would have supported with the same answer.